Good afternoon. So this is a projectile problem, as you can see, and let's do this numerical, jointly. Now you can see there is a basketball player, and he is trying to take a foul shot, right? So he's standing, and his hands are up, and he's projecting the ball upwards, right? And you can see the height of his hands above the ground is given to be h1. So you can see that as the height, right? This is the height which we are referring to. And the height of the basket, is h2. This is h2. And there are two other things which are given to you in this problem. And you can see that the hand and the feet also have a distance, right? So you can see that the hand and the distance have a gap between them, which is let me use a different color, which is this gap, right? So there is a gap here. But the basket is located at a distance of d2 from the hands. Now, if you see this and compare this to a normal projectile, you find that normally, an oblique projectile starts from the ground. And when it starts from the ground, you can use your standard equation of trajectory or split the motion in y-axis and x-axis. But this is a very typical situation in which the projectile is not starting from the ground, but above the ground. And also there is a distance, a horizontal distance which has been given to you. Now this, if you compare this to a normal standard projectile, now your ground does not exist, right? But the motion is still projectile. Now, how do you handle such a situation? Now, let me just give you the strategy, and you can also, think about it. So if you see the ground now is the hand of the person. So the hand, let me just point out this position, represents the hand, right? The hand represents, or the ball position initial represents your origin. What was there on the ground is now in the air. Now let's see what are the coordinates of this origin if the position of the ball is treated as a ground. Now you can see horizontally the distance between the basket and the hand is d2 minus d1. So the true distance, which is between the position and the basket is this one, right? And this is d2 minus d1. Similarly, you can see the vertical distance between the hand position, which is your new origin, and the basket is only, this much. Let me just use some separate color and show you, right? This is, so essentially this is h2 minus h1. So we can say that this is a projectile, where the start point or the origin, is at a distance of d2 minus d1 horizontally from the basket, and the basket has attained a height of h2 minus h1 from the origin. So this actually reduces to a normal projectile, except for the difference that the normal projectile starts from the ground, but this projectile starts from some different coordinate. And now you can apply the equation of trajectory where x is equal to x tan theta minus gu squared, cos squared theta, etc. So that equation of trajectory can be straight away applied because the x, the position of the ball with respect to the origin. You also know the y of the ball with respect to the hand, which is again the origin, right? So what we have, our strategy in this question was that whatever we calculate in terms of x and y, which is the final position of the ball at the basket, is calculated with respect to the initial point in the horizontal direction and the vertical direction. So you know the y, you know the x, and now you're free to apply your standard equations of motion. So this question became a bit difficult because the projectile did not start from the origin, which is a normal 0, 0, but started somewhere in the air. So what I did was I just shifted my origin to the initial position of the player, which was here, right? So that became my initial position. And then from that initial position, I calculated how much displacement is there in the x-axis and how much displacement is there in the y-axis, and then use the equation of trajectory to solve the problem and get the initial velocity. I hope this was clear to you. Please send me your feedback and suggestion. Thank you very much.